let's start with the infrastructure. Okay, Exchange is dependent on many infrastructure components, AD, DNS, good reliable networking, and so forth. So all of these things have to be designed properly before you can design your Exchange HA solution. Okay, so let's talk about Active Directory first. The general guidance is fairly easy. We simply recommend that you follow the Active Directory team's guidance for your Active Directory deployment. Use their definitions for AD sites. Know when they're well connected, know when they're not, know when it's time to take one site and turn it into 2 sites. Just follow their guidelines. Our solution works really well both in a single site and in a multiple AD site configuration. There are some nuances that we have around the network, but by and large, there's nothing unique or special to your AD site topology that's going to affect your DAG design. Now, AD site topology is used by Exchange. We use it primarily to figure out the sightedness of the servers and the sightedness of the mailboxes. You know, by and large, mostly the CAS and hub servers in the site will service the mailbox servers in that site. And I say mostly because, as you'll see later, there is the possibility, for example, for a CAS in one site to be servicing a mailbox server in a remote site. You'll see what I mean in a little bit. Now, DAGs can span AD sites, and they can span subnets without any special configuration. That's actually not new to DAGs. We were able to do similar things with CCR in Exchange 2007, SP1 and later. Now, we do have some requirements around when you should extend the Active Directory site. Okay? The Active Directory site should span multiple locations when you have LAN speeds between them. 10 millisecond or less connectivity between them. So say, for instance, you're a company that has 2 data centers. One data center is in one building, the other data center is in the building across the street. Okay? You may have very well-connected networks between them. Okay? They may be such that they're LAN speed, and you've got a single AD site across both of those data centers. Or you might have a data center here in Auckland and perhaps a data center somewhere in Singapore. Okay, obviously, those are going to be 2 separate AD sites. You won't have the bandwidth to make them LAN speed. So those would be 2 separate AD sites. So that's the guidance that we're talking about. Now, for the network, there's no real special considerations. Okay, and in fact, we reduced our support requirements. In CCR, we required 2 network cards for every single member in that solution. Now we only require 1, just 1 network card. We do recommend redundancy and resiliency, but if you want, you can get away with just 1 network card in each DAG member. Now, we do have some requirements, though, particularly for cross-subnet communication. Okay, we support multi-subnet just fine, but there is a configuration that you wanted to put into place to prevent the network on one interface from talking to the subnet network on the other interface. So here's an example. We've got 4 mailbox servers here. And each of these are multi-subnet. They have a single mapping network and a single replication network in them. If you're not familiar with what those networks are, those are the networks that we talk to other Exchange servers with, or the network that we replicate through, respectively. And I'll go into those very deeply in the deep dive later this afternoon. But the point is, whether it's CCR or a DAG, you've got a multi-subnet mailbox server. Subnet 1, you might think of this as the private, using the old vernacular. You might think of this as the public, using the newer vernacular, and so forth. Now, what we want to do is we want to make sure that Subnet 1, the mapping network, is able to communicate freely with the mapping network on all the other members. But we want to make sure that the mapping network on Mailbox 1, in this case Subnet 1, can't talk to the replication interface on the other mailbox servers, in that case Subnet 4. Okay? If we allow a mapping network on one box to talk to a replication network on another box, or if we allow a replication network on one box to talk to a different replication network on another box, we get what's called heartbeat crosstalk. Okay, we get heartbeat traffic that grows exponentially based on the number of servers that you have in the DAG. Now, if you only have 2 servers that you're stretching, it's not such a big deal. But if you suddenly go to 3, 4, or up to 16 servers, now you've got a lot of heartbeat traffic going across your network. And that is something that you want to suppress. So you want to suppress it by blocking this communication. How do you block the communication? Generally, it's going to depend on your environment. The easiest way to do it is to use router ACLs. Go to the router and configure it so that these subnets simply don't have a communication pathway between them. Once you do that, that solves everything. If you don't have a router that supports ACLs, you can get away with setting static routes using NetSH to do the same thing. But by and large, the easiest way to do that is going to be through the use of router ACLs. The other reason that you want to do it, even forgetting the crosstalk aside, the other reason that you want to do it is if we can heartbeat multiple interfaces, then that eliminates our ability to distinguish between a single network failure and a server failure. Okay, you might have lost the mapping network, but if cluster can still talk to the box of the replication network, it's going to mistakenly believe that the service is still up and capable of servicing clients. You want to prevent that from happening, and to do that, you want to block that crosstalk. Now, how many of you have multiple data centers and you want to deploy a DAG across multiple data centers? Okay. So the guidance here, and by the way, we talk about it in the site resilience section, but the guidance in terms of latency applies to all DAG members regardless of how you deploy them. So whether all your DAG members are in the same data center or you've deployed them to multiple data centers, we require no greater than 250 millisecond round-trip return latency. Okay? And that's between all DAG members. So you might have many that are well connected, you might have some that are not so well connected, but wherever they are geographically, they all have to have less than that round-trip latency. Okay? And that's for a couple reasons. One is, obviously, if it's a highly latent network, we're not going to be able to get those logs off that box as quickly as we should. Okay? And that's the whole point of continuous replication and using the solution is to ship those logs as fast as you can. The other consideration, and this goes back to the client connection and how a CAS in one data center could talk to a mailbox server in another data center, is now you've got a cross-site client experience to deal with. And when the latency increases in a cross-site client experience, then things like OA become very slow, search becomes extremely slow, online clients become generally unusable, and so forth. So we have this support boundary of no greater than 250 milliseconds round-trip return latency. Now, a couple of the other things you're going to want to do are around DNS records. Okay? You're going to have namespaces, and we'll talk about what those namespaces are, but you'll have namespaces in each of your data centers. The names that users connect to for SMTP, for Outlook Web App, for Outlook Anywhere, and so forth. These namespaces will have DNS entries, and it's extremely important in a site resilience configuration that the time to live on those DNS entries be as short as possible. And generally, you're going to want to make it relative to your SLAs. So for every hour SLA that you have for your recovery time objective, you're going to want to set a 5-minute DNS TTL. Okay, so if your RTO is already 1 hour, just set the TTL on the DNS records for those namespaces to 5 minutes. Okay, it's a very short time. It ensures that the clients will pick up those changes right away without having to manually refresh their DNS cache. Now, one thing to look out for, and this actually caught us in some of our site resilience tests. We do regular testing of the solution. We've got a data center in Tukwila, which is outside of Redmond. We have another big data center in Singapore. We replicate between the two. And we do site resilience tests between them all the time. One of the things that tripped us up, we had the DNS records all set to a 5-minute TTL, but some of the records we were dealing with actually ended up in different DNS zones. Okay, and as a result of that, they ended up with different TTL settings after we had gone back and set that. So whereas we expected a TTL of 5 minutes, we actually got 20 or 30 minutes on some of our records. And it turns out it's because they were in different zones and those zones weren't configured appropriately. So you got to watch out for all your DNS records. You might not be the DNS administrator. You might have to get a DNS administrator to do this work for you. And it's important that they understand the TTL's got to apply to the records regardless of what zones they're in. Okay, let's talk about site resilience models. There's basically 3 different models that you're going to be using. One is based on the data center model, what sort of data center situation you have. One is based on the namespace model, which namespaces you're going to use in which data center. And the other model is the user distribution model. And that's how that's going to be determined by how your users are distributed across your data centers. Okay, so let's talk about the namespace planning first. That seems to be the thing that trips people up the most. The reason it trips people up, I think, is because there's a difference in Exchange 2010 that we haven't had before. Even with 2007, when we had standby continuous replication, being able to replicate to standby data centers, you still didn't really need all of the infrastructure services there because those services wouldn't come into play until you actually activated and moved the clustered mailbox server over there. Well, we've moved away from that model where we're replicating a mailbox server identity and moving it around. There's no such thing as a clustered mailbox server anymore. Instead, we have failover now at the database level. And because an individual database can move between data centers, it needs services to support it in each data center it can move to. So there's now an assumption when you're in a site resilience configuration with 2010 and you're using DAGs, you're going to need to have the live services there. You're going to need CAS there to service it, Hub there to service it, and obviously AD and DNS as well. But this is a big change. You're also going to need separate namespaces. Okay, you'll need a namespace for Outlook Web App, one for Outlook Anywhere, one for Exchange Web Services, one for Exchange ActiveSync, one for SMTP, one for POP and IMAP if you're using that, one for the RPC Client Access Service, which is new in 2010, and one namespace for SMTP and one for Auto Discover. Okay, so these might be new things for you if you haven't dealt with this before. Now, that isn't to say that you're going to have different namespaces for all of those. You might simply use mail.contoso.com for each and every one of those namespaces, except, of course, Auto Discover, which would be autodiscover.contoso.com. But the point is you need to cover all of those clients and protocols that you're going to be servicing, and you need to do that in each data center. Now, along those lines, when you publish those namespaces are accessed via DNS first. Okay? What we recommend now is that you use a variant of DNS called split DNS. It's a configuration variant. And basically it means you've got the same DNS names and records inside on your internal DNS and outside on your external DNS, but they resolve to different IP addresses. Obviously, the ones on the inside are going to resolve to internal IP addresses. In this case, the virtual IP of the CAS array. We'll talk about the CAS array in a little bit. Outside, they're going to resolve to the endpoint of your reverse proxy or your firewall, like your TMG server, if you will. Okay? So you'll need to use some form of DNS, and we recommend this because it keeps things simple. You get to minimize the number of host names that you use in the solution. You don't have to use different host names for internal, different host names for external. Users only have to remember one namespace. Doesn't matter if they're at home using OA or in the office using Outlook and configuring their profile for the first time. They just have one namespace to remember. And here's generally what it's going to look like in a multi-data center environment. Here we're using the primary namespaces of mail, POP, and IMAP, etc., .contoso.com. Over here for our second data center, we're using mail.region.contoso.com. Obviously, it doesn't have to be region. It can be anything that you want it to be. It doesn't have to be a variant of the other namespace. It can be any other namespace that you want. It just has to be a viable, live, serviceable namespace. So when we're looking at things like the CAS array, we might use one namespace internally and a different namespace externally. That's okay. The users won't ever have to know the internal name. That'll get resolved by using the internal and external URL parameters. Okay, so it makes the namespace design very easy to do. But the point is you need a separate namespace. Now, one other thing that this is showing is, again, the same records in both external and internal DNS in both data centers. Okay? Again, the difference is external DNS is going to resolve here to this endpoint. Internal DNS is going to resolve here on the CAS arrays. That's the only difference. Okay, certificates. Who enjoys working with certificates? Who enjoys laughing at people who enjoy working at certificates? There you go. There's the hands. Yeah. I heard one MVP describe certificates in Exchange 2007 as about as much fun as gouging your eyeballs out with a spoon. Now, I have both my eyeballs. I've never gouged them out with a spoon or anybody else's. But if it's that bad, wow, that says something. And it did say something to us, actually. We did a lot of work in Exchange 2010 to make certificates a lot easier to use. In RTM, you may have noticed the new certificate wizard that we have that allows you to do the certificate request to an online provider right through the Exchange Management Console. Or you may have noticed the GUI that shows you what certificates are in use. And so you can configure them. Why is that important? Because you're going to need certificates in your deployment. You can't do a site resilient or a highly available deployment without them. Now, our best practice recommendation is to use a type of certificate called a subject alternative name, SAN certificate. Okay? It's simply a special kind of certificate that lets you use multiple names. Don't be confused with a wildcard certificate, which is also a special kind of certificate that lets you use multiple names. The difference is the SAN certificate has the actual names in it. A wildcard certificate uses a wildcard, like an asterisk, like star.contoso.com. Okay? What's the problem with star.contoso.com? Okay, the problem is it's for anything. for anything. And if somebody gets a hold of that certificate, they can spoof your entire domain, everything. That's why there will never, ever be a wildcard certificate in use for Microsoft.com or any of our other web properties. It's too much of a security nightmare. Okay? But the SAN certificate is not a security nightmare. That's tied to specific names. Okay? So it's the SAN certificate that we recommend using. Why? Because you saw those namespaces. You're probably going to have a couple different names that you're going to need to use. Probably one for each data center, for example. So using a SAN certificate, yes, it's a little bit more expensive to get one of those, but you have the flexibility. Okay, you have the flexibility to use multiple names. You have the flexibility to take that certificate and put it on multiple endpoints, put it on your CAS servers, put it on your reverse proxy servers, and really minimize the number of certificates that you have to purchase. And that's a good thing. Now, how many of you are using OCS? Okay, so be warned, you might need to purchase a second certificate to get the OCS integration. OCS has some unique certificate requirements that Exchange doesn't have. For instance, they need the server name in their certificate. We don't. They also require a certificate that has greater than 1024 bits. We don't. Okay, so you're probably going to have to buy a second certificate. Now, if you are leveraging these certificates, you have to make sure that the certificate principal name, remember, you're going to use multiple names, but whatever is your primary name, like mail.contoso.com, that has to match whatever you put in the MSSTD provider. Okay, so it's this commandlet that you'll use to set that. And if you've been in Outlook and you've gone into Outlook Anywhere's configuration settings and you check that box that says only connect to these servers that have this in their certificate principal name, and that's, that field has the MSSTD colon and then the namespace in there, that's what we're talking about. That's what has to match the certificate principal name. If it doesn't match the name, Outlook won't connect unless you uncheck that box. And that box is checked by default. Okay? And generally, you want to keep that box checked because it's a nice secondary security check inside of Outlook to make sure it's connecting to the right server and not some spoof server that's trying to get your data. Okay, let's talk about the user distribution models. And this simply refers to where your users are located based on your data center topology. So you might have a data center that's your primary data center. All your users are located in there, and there's nobody in a standby data center. Maybe it's warm, maybe it's hot, but there's no users there. Okay, we would call that an active-passive model. Okay, let's say you had active users in both data centers. Obviously, we would call that the active-active model. And that actually is going to drive your DAG design deployment as you extend your DAGs across multiple data centers. This is going to directly determine the number of DAGs that you'll actually end up deploying. You'll see what I mean by that in a minute. But first, we need to talk about the client access array. Okay, this tends to catch people off guard because, well, for one thing, we don't talk a lot about it in our documentation. Even though it's a necessary critical part, it's just an object that you create at one time, so there's really not too much to tell you about it. But basically, it's an object that represents either one or a group of CAS servers in that AD site. Okay, now, every AD site can have only one CAS array. So if you have multiple AD sites, you'll be doing one CAS array for each AD site. It's a very simple thing to create. You just create it, one-time thing, and then any databases that are created after that will automatically be stamped with that property. Databases that already exist, you have to go in and run that command at the bottom to reconfigure them for the array. But this basically sets up the abstraction layer for the client access server across the mailbox server. Hey, remember now, in Exchange 2010, all clients, including all MAPI clients, connect to the CAS server. Okay? For load balancing, for redundancy, you want to create the array, and you want to put all the CAS servers in that site into that array. Now, after you've got the array, then you can start looking at things like your DAG design. Okay, so the DAG design refers to things like the number of servers in the DAG, the number of database copies in the DAG, and so forth, and how they're laid out. Now, there are some rules with respect to database copies. The concept that we had in 2007, known as local continuous replication, no longer exists. That means every DAG member can only have one copy of a given database on it. Okay, it can have up to 100 databases, but only one copy of a given database. There's no LCR equivalent. Now, the number of unique databases inside a DAG is determined by the number of servers that you have and the number of copies that you throw on there. So if we look at the maximums where you can have 100 databases per server, 16 servers in a DAG, that'll give you a total of 1,600 copies. Now, of course, you can have 1,600 copies no matter what, but in this case, we're doing one unique copy of each database. So you have 1,600 unique databases. If you want to do multiple copies, then the number of unique copies drops. If you do 2 copies of every database, you'll get 800 unique databases. If you do 3 copies, you get 533, and so forth. Either way, it's a staggering number of databases. And when you consider that our maximum database size is 2 terabytes, that's our recommended size, not our actual size. Our actual size is actually 64 terabytes, but don't grow that big. Stay at 2 or less. But consider 1,600 databases with 2 terabytes of data in them. Okay, 3,200 terabytes of data. Who's ready to back that up? No? No one? Me neither. Okay. Now, there's 2 types of database copies. We have the normal, what we call the HA copy. That's the copy that's always kept up to date, the passive copy. And we have what we call a lagged copy. Okay, the lagged copy, again, we introduced in 2007. It's not new to 2010. The lagged copy is where we're delaying replaying of the log files on the passive side. Delaying for X, where X is what you get to set, up to a maximum of 14 days. Okay? Lagged copies have storage implications. Obviously, if we're delaying replay of those log files, we're having log buildup on those passive copies. Okay? And that means you need to account for that in your storage design. You need to ensure you have sufficient capacity on your log drives to account for that growth. So it's going to be whatever your log generation rate is per day for the number of days times your replay lag interval plus 3. We always like a little fluff factor in there of about 3 days, just in case something happens, you need some extra maintenance time, you can't get those logs committed in time, and so forth. So just keep that in mind. Now, once you have database copies, what do you do with them? Well, normally the system's generally designed just to activate them in response to a failure. The server fails, the network fails, the storage fails, and the system recognizes that and then activates the next best copy. We actually call that best copy selection, and I'll explain it in detail in the deep dive if you come to that. But there are some situations where you don't want the system to automatically activate your copies. So, for instance, say your data center, your secondary data center is a true standby data center. Okay? It's only going to be activated when the administrator decides to activate it. So you don't want the system to do that automatically. So you might block those servers or those databases from being activated automatically. In another situation, maybe you've deployed lagged copies. You want the protection, the unique protection that you get from a lagged copy, and having that back in time, that point in time copy you can go back to. You don't want the system to automatically activate that, because if it does that, first, it destroys the lag nature of that copy, and second, it's going to take a long time because activation requires it to replay all of the outstanding log files. So you probably want to block those copies as well. And then the last scenario is, well, you have to upgrade a server, or you've got some maintenance you need to do, or a hardware issue you need to deal with. And so you want to block that server from having any of its copies be activated as well. And what's interesting about blocking for activation is that's all it blocks. It doesn't block log shipping. It doesn't block log replaying. It doesn't block log inspection or log truncation or anything like that. All it does is say, don't let the system automatically activate these copies. I'm the administrator. I'll take care of them when I need to. Okay? And there's 2 ways to do it. You can do it at the server level. So you've got all the standby servers in that foreign data center. Or you can do it at the individual database level. Maybe you need to do some maintenance on the storage underneath one of the databases, and you're just activation blocking that one database. Or maybe you just have one lagged copy, and you just want to block that one lagged copy from being activated. Now, let's talk about DAG sizing. Okay, the big takeaway, the inherent lesson here is that larger DAGs, by their nature, provide greater resiliency. And that's kind of a duh when you think about it. I mean, obviously, the more stuff you throw in there, the more failures you can tolerate is what it comes down to. Okay, but that's the key. If you're deciding whether I should do 2 3-server DAGs or 1 6-server DAG, go for the 1 6-server DAG. Okay, you'll always get greater resiliency out of that. And that has to deal with issues of quorum and witness. But it also has to deal with database layout and the number of opportunities you have to isolate copies from one another and isolate failures from one another. Now, what do we mean when we say plan for quorum? Okay, planning for quorum underneath every single DAG is a Windows failover cluster. Windows failover cluster uses a quorum-based model. And again, I'm going to go pretty deep into this in the deep dive, so I'm going to kind of skim the surface a little bit here. But the basics of this is, here's my DAG. I've got a DAG with 4 mailbox servers. It's extended across 2 sites. Here's mailbox server A, B, C, and D. And because this is a DAG with an even number of servers, I also have my witness server right here that's external to the DAG. So from a quorum perspective, I've got 5 elements or 5 voters. Okay? So a quorum of 5 will get me the majority. So what happens, this by the way is the WAN router, what happens if the WAN router goes down? Okay, well now I've lost connectivity with a couple of my nodes. But I still have the majority of my voters up over here. I still have 3 out of the 5. So I maintain quorum and life is good. But now what happens if someone says, oh, I need to do maintenance on this hub transport server and I'm going to power it down, take it offline. Well, now I've lost quorum because I'm down to 2 out of the 5, which is a minority. It's not a majority of the number of voters. And again, we'll go through quorum a lot deeper in the deep dive, but I think you can kind of get the basics of how this works. It's majority rule, basically. Okay, now, let's say, for example, I've got the same servers, only this time I'm adding a couple extra servers to my DAG. And here's the interesting thing about this. These 2 servers are co-located hub and mailbox roles. They don't necessarily have to have mailbox databases or mailbox database copies on them. Okay, in this case, they might be database-less servers that I'm using for no other purpose than to increase the number of votes I need to maintain quorum. Okay, so for example here, now we've got 1, 2, 3, 4, 5, 6, plus our witness server over here, we've got 7 quorum votes. We lose the WAN, we still have 5 quorum votes. Somebody takes down the witness server, we still have 4. We still have a majority at this point. Again, just going back to the basic principle that the larger the DAG, the greater the resiliency you get. The more number of servers you can tolerate losing and still keep the solution up and running. You lose quorum, solution comes down and requires manual intervention. You do things that maintain quorum, life will be good for as long as these servers are down. Now, the question, and I actually got this earlier in the virtualization session yesterday, is how do I know when I deploy 1 DAG or 2 DAGs? Single DAG or multiple DAGs? Okay, well there's really only 2 drivers for that. One driver is obviously if you need more than 16 members. A DAG can only have up to 16 mailbox servers, and if you need something bigger than that, you have to go for multiple DAGs. The other reason is when you want to account for that active data center deployment where you've got users in both data centers and you need to have them both stay up and running in the event the WAN goes down. Okay, so what does that look like? Remember, going back to what we had here, we know we lost quorum on this side, but just as an example, we now have users in both sides. Okay, so if we take a 4-member DAG, extend it across there, there's our witness server, we lose the WAN, this whole side is down. They don't have any service. Okay, they don't have any local service, and obviously their network is down, so they can't even connect to the surviving members that are providing service in the other data center. Okay, so what's the solution for that? Well, now the solution is 2 DAGs. Instead of 1 DAG, do 2 DAGs. Here's DAG 1, here's DAG 2. The witness server for DAG 1 is in this data center. The witness server for DAG 2 is over here. So if we lose the WAN link in this case, it's not really a big deal. Well, it's a big deal. You lost your WAN. But it's not a big deal from the solution standpoint because although you're losing half of the DAG on each side still has half of it that survives. It's got a sufficient number of members and a witness server there to provide it with enough votes to maintain quorum and stay up and running and continue servicing its local user population. So that means in this architecture, a WAN failure is only going to stop replication for you. It's not going to interrupt service or data access. Keeps things up and running for your users. So that would be the other driver for going to multiple DAGs. Now, generally, you're going to architect the solution. We talked about architecting it for resiliency and how larger DAGs provide greater resiliency. You're really just going to architect it based on the failure scenarios that you need to account for. So if you need a failure scenario that says we have to have a solution that's up and running when we have 2 server failures, you'll have at least 4 servers in that solution. If you say, well, we can tolerate only 1 server failure, you could get away with 2 or 3 server DAG. You say, I need 3 server outage, it's going to be even more numbers and so forth. Okay, so you're going to be designing based on the failure modes you need protection against. But regardless of your design, you do want to design all servers so that they're capable of handling 100% of the load. Okay? That's particularly true if you're just doing a 2-node DAG, but it's going to also be true if you're doing a 3, 4, 5, 6, and so forth node DAG as well. The servers have to be sized to handle more than the active load they're currently handling. They should be sized to handle all possible active databases. Okay, so that's going to change perhaps the sizing exercise that you do in JetStress when you're figuring out how your disks are laid out. It's going to change the inputs you'll put into the mailbox server role requirements calculator to make sure that your DAG layout is correct and accounting for that. Okay? Because the last thing you want is to have some members go down and have the survivors not be able to handle the resulting load. Because that'll just tip the server over, but in a different way. So you want to avoid that from happening. Now, one of the things that you can do, and this is something that we do in MSIT, and this is actually why this setting is in here, because it came in at their request, and it's a great thing for you all to use as well, is there is a way where you can say, I don't want any more than X number of databases active on this server at any given time. So you might have a server that perhaps supports 50 passive copies, but you might want to tell the system, I only want 35 of them to be active at any given time. That's what the max active databases parameter will do. You set that value to the maximum number of active databases, and then when that value is reached, and Active Manager needs to do its best copy selection, it won't activate any more databases on that server because it's at its maximum. It'll find another best copy to activate and use that server instead. Now, what's also interesting is you can take the same number of servers and the same number of database copies and lay them out in ways that work well for you or lay them out in ways that don't work well for you. So here's an example of how it's really all in the layout. Nothing fancy here, 8 servers. We've got our active copies up here in the lighter color, the passive copies with the little tick marks to indicate their copies down here in the green color. This is how we've laid it out, 8 servers total, 40 databases, 2 copies of each database. Okay? So what happens if we lose one server? Well, life's still good. We lost all of these active copies over here. We did lose the passive copies, but that's not a service interruption. It's just losing redundancy in the data. We lose these active copies, but that's okay, because here's the passive copies that just got activated for each of those on server 1. Life is still good. Now, what happens if we have a second server failure, which, again, because we've got 8 servers and a total of 9 votes, remember, we could lose up to 4 servers and still keep things up and running, right? Okay, but let's say we've laid things out like this. Life could still be pretty good. We just lost 2 servers. Again, we lost our redundancy in the copies, but we also have these activated over here, so life is still good. Life is up and running. No outages, so forth. But this layout presupposes that it's going to be these 2 servers that fail at the same time. What happens if this server fails and server 1 fails instead of server 7? Well, now that's a problem, because remember what happened when this failed in the first place. Where did all these copies get activated? The only other copy that they had, server 1. Okay, so what happens if server 8 and server 1 go down? Server 8 and server 1 are down, and none of its copies are active anywhere. You've actually got an outage for all these users on this database as a result of this inefficient layout across the DAG. Okay, so it didn't matter in this case that you had all these servers that you could copy databases to. Lose the wrong 2 at the same time, or not even lose them. That could maybe have a hardware failure, and then somebody takes this one down for maintenance. Okay, so it's not even an unscheduled outage. It's a regular maintenance outage that ends up taking everything down. So how could things be better? Well, let's simplify it. Let's just say we've got 4 servers, 12 databases this time, but we're using 3 copies of each database. Okay, again, the number of servers that we're using is a multiple of our database count. So how does that look? Again, very similar. We've got our active copies in white. The first passive copy is the same color as the second passive copy, but one has a single tick mark, the other has a double tick mark, so you can tell where it's one passive versus the second passive. Okay, so again, we'll lose 1 server. Server 4 goes down, not a problem. The active ones on server 4 were DB10, 11, and 12. We can activate those on server 1, 2, and 3, respectively. Life is still good. We've lost only 1 server at this point. Now, we lose our second server. Again, not a problem. Life is still good. We've lost 7, 8, 9, but that's okay because 7, 9, and 8 are still copied because we have multiple copies on server 1 and server 2. So you just saw an 8-node DAG not really be able to tolerate a double server failure, and you saw a 4-node DAG be able to tolerate it really well. Okay, what's the difference between the two? The number of copies. Okay, the number of copies that we had in the 8-server DAG was 2. So of course you lose 2 and it's game over. The number of copies we have here is 3. But we've got 4 servers, so if you lose 3, you lose majority anyway, and it's game over. So there's no need to go greater than 3 copies and still get that resiliency against multiple server failures. Okay, it's all in the layout. Now, the layout, by the way, doesn't just refer to the servers and the databases and the way they're laid out. It also refers to the way the servers are laid out in your data center. Okay, and how your storage is laid out in your data center. You know, I gave the example earlier, I can't remember which session, but earlier, whereas you buy all these fancy servers and then you put them all in the same rack. Okay, and then somebody comes and unplugs that rack, and then the next thing you know, all your servers came down, even though they were separate DAG members. Okay, so it's not just enough to do isolation of the databases or isolation of the servers. You have to think about separate power for each of these servers. You might have to think about separate cooling for each of these servers. Perhaps separate routers and separate networking equipment for each of these servers as well. If you have all of this wonderful servers separated all, but they're all connected to the one same router, and that router goes down, everything's coming down. So you have to build in redundancy into the solution, eliminating all single points of failure where economically reasonable. And that's the key, economically reasonable. I'm not saying go spend a ton of money and shore everything up. It has to be based on your business decision to go to HA in the first place. Now, the storage architecture, whether you use RAID or whether you're able to take advantage of other options like JBOD, just a bunch of disks, in other words, unrated disks, that's going to largely be driven by your copy architecture. Okay? But we do have specific guidance as to when you should use RAID or JBOD. The big takeaway here is if you have 2 or fewer copies, you definitely want to stay on RAID. Okay, we don't think 2 copies is enough copies for you to eliminate the protection that RAID gives you. But if you scale out to 3 or more copies, well, at that point we think now it does make sense to look at lower cost storage, to not have to have the redundancy in the storage stack and instead move that into the application stack, since after all it's the application that knows the difference between good data and bad data. And so that could drive you to a JBOD solution. One thing I will caution you, though, is it's very attractive to look at a solution like JBOD and to think about how much money you can save by going with that cheaper storage. I want to caution you, though, don't let the cheaper storage drive your design. Rather, figure out your design first. Figure out the number of copies. And if it turns out that the number of copies you have is 3 or more based on your resiliency needs, that then gives you the opportunity to go to JBOD. So you design for HA first and then leverage JBOD if possible. You don't design for JBOD and try to fit that into HA. It's a very important distinction to make. Okay. Now let's talk about replication considerations, because after all, we're replicating data. And we're doing it asynchronously, either through actual transaction log files, or in SP1 we've also introduced a new form where we actually replicate log buffers across the system as well. But either way, replication is always going to be from the active copy, the copy that's changing, to the passive copy. If you have multiple copies of the same database in a remote data center, we're sending those changes over the wire twice. Okay? If you have 3 copies, it's going over 3 times, 4 copies going over 4 times, and so forth. Okay? We don't have any deduplication. We don't have any log shipping from passive. We can seed from passive. If you already have a copy over there and you want to make a second copy, you don't have to send the whole database there. We can seed from that local copy. But log shipping always has to come for the active, because it's the active that's the source of the new data. Now, we do have built-in compression and encryption, and it's the compression that could help you out here the most. In MSIT, when we looked at our savings, when we had compression enabled, we're about 30% savings on the wire with compression enabled. It's going to vary, though, based on log traffic. Okay, so our log traffic might not be the same as yours. Probably not. So be aware that your compression values are not necessarily going to match. It's also to a certain extent based on the content itself. The content's already compressed. There's nothing we can do to help out there. If it's not compressed, we may be able to compress it down quite a bit. So there will be variances, but on average we see about 30% in MSIT. Now, the other thing I mentioned is that block mode. This is only active when continuous replication is already up to date. Okay, so you've already got a good network and it's able to pump the data very fast and the copies are able to keep up. If the copies aren't able to keep up, it's just going to go back to normal log shipping mode and ship those logs as fast as it can. And again, I'll talk a bit more about block mode in the deep dive later this afternoon. Now, content indexing. A lot of people overlook content indexing, but it's an extremely important consideration. For online clients, for OA, for mobile devices, that's their search experience. That's what lets them search through that fancy new 2 or 5 or 10 gigabyte mailbox you just gave them. Okay, if you give them a 10 gigabyte mailbox, but they can't search through it, you might as well give them nothing. So the search is where we excel in the client experience. But the search also needs to be copied around. And we do maintain a copy of the index on the passive copy, but all the changes, just like the database, come from the active copy. Okay, there's no separate indexing that's done on the passive copy. We get those changes from the active copy, and we ship them through the same channel we send the logs or log data through. Okay, one difference though, that traffic is not compressed, nor is it compressible. Okay, so that means you're not going to have any savings by virtue of the fact that you turned on compression. That's only going to help you with the log shipping. Okay, this is going to be uncompressed, and so you'll need to look at the mailbox server row requirements calculator to figure out what impact that's going to have on your network. And of course, the impact is going to be dictated again by your message and usage profiles. Okay, so small scale architectures. If you're a small company, if you've got small office, branch office, you could get away with a 2-server DAG most likely. You're going to need a third physical server somewhere to act as the witness server. But in terms of the exchange licenses, you can get away with just a 2-server DAG. Other options include maybe using virtualization. How many of you were at my virtualization session yesterday? Okay, not too many. But I gave you many examples of scenarios in which virtualization makes sense for Exchange. So you've got some options there as well, particularly in the small and branch office where you can enable up to a 50% reduction in the number of servers you need. The example I showed had 7 servers, 7 separate servers that were reduced to 3 physical servers. Okay, so that's a significant savings there. And of course, you could do 4 physical servers as well, a little bit more hardware. You're not saving anything because there's no virtualization there. And it's a little bit more licenses as well. But if the office is that big enough where it needs that kind of resiliency or that kind of power, that's also another option for you. Okay. The last thing I want to talk about is what the client experience is like. Because after you've designed it all, after you've got it all in production and people are using it, you're going to want to know what to expect. Okay? And generally, we're going to focus on the Outlook client experience because the client experience will differ quite a bit amongst the other protocols and clients. And I do have a table that summarizes it. But I largely want to focus on Outlook because that's what most people are using. Now, the good news is that for the 3 types of scenarios that we have, for things like a database or data center switchover, you've lost an entire data center, or when we have a single database star over, in case you're not familiar with that term, star over is our shortcut term for failovers and switchovers. Okay, so failover is when the system automatically takes corrective action, activates the copy. A switchover is when the administrator manually does that. They manually activate a copy and so forth. So anytime a database goes over to a different data center, whether it's a failover or a switchover, Outlook is going to behave the same across all Outlook versions. Anytime that you have a data center switchover, the entire data center moves over, Outlook is also going to behave consistently across all versions. It's really the experience when you have just a single database moving between sites that you run into nuances between the Outlook clients. Now, the default behavior, by default, if I'm in data center 1 and I'm talking to a CAS in data center 1 and my database switches over or fails over to data center 2, the default client experience is for me to maintain my connection with CAS and Data Center 1, and that CAS box in Data Center 1 will then talk to Mailbox in Data Center 2 on my behalf. Okay, so that's RPC mapping traffic going across your WAN at that point. Okay, that's the default behavior. Now, you could try to get a redirect. You could go and you could try to change the RPC client access property on the database. I showed you the command to set that property earlier. It's the command you use to set it after you've created the array so that you can set it for existing databases. If you set that, Outlook may or may not honor that. Okay, it'll still do some updating. It'll still connect to the right service, but it might not update the actual user profile and make that a permanent change. So here's how that looks. Okay, so we've got our DAG. We've extended it across 2 data centers. These 3 green ones are my passive copies. The red one is the active copy. I'm using Outlook 2010, and Outlook 2010 has a home server of this CAS server, and that's also the RPC client access server property on the database. So everything's pointing to the same thing right now. Outlook says, use this CAS server. The database says, use this CAS server. Now, what happens when we have a database switchover or failover? Now the active database is over here. Well, in the case of Outlook, the RPC client access server does not change. The database still has that value there. Okay? It's never going to automatically change itself. If it gets changed, it's because an administrator changed it. Okay? So that stays the same. The home server stays the same. In other words, Outlook's profile hasn't changed at this point. And cross-site connections are allowed, so Outlook's going to talk to its local CAS, and that CAS is going to go across the WAN and talk to the remote mailbox server. Okay, that's what we call direct connect. This is the default behavior. Now, what happens though if you accept the default behavior, but then after the database starover occurs, you go ahead and you update that RPC client access property? Okay, so the difference is going to vary based on which client you're running. So we had the database failover occur. You manually change the RPC client access service property on the database to point to this CAS server now. We were pointing here. Now we're pointing over there. So Outlook, the auto-discover feature in Outlook actually detects that change, but it does not update the profile. Okay? It's going to say the Exchange administrator has just made a change that requires you to restart Outlook. And so they'll restart Outlook, but because the profile is not updated, it's not using the new value. So it's going to connect right back to CAS Pry, and CAS Pry is going to connect to the mailbox server across the WAN. Okay, Outlook, one more thing. What happens if this CAS server's gone? Then Auto-Discover does the right thing. Auto-Discover says, okay, I detected that earlier change, but the server was still there. I can still talk to it, so I'm going to still use it. In this case now, the server went away. Or maybe the administrator got savvy and said, oh, Outlook's still talking to it, and powered it off. Okay, so now that server's gone, Auto-Discover will actually kick in at this point, detect the change, update the profile, and allow them to reconnect after the restart to the new CAS server. If they don't restart, Outlook's going to stay in a disconnected state. But if they do restart Outlook, which a lot of users do when Outlook won't connect, it then will have its profile updated, so it will connect to CASSEC, and then CASSEC will be talking locally. Of course, remember, we still have the client itself located over here. So if there's any high latency in here, that's going to diminish the client experience. Okay, now what happens here? We've got the same change. This is Outlook 2007. Outlook 2007 does the same thing as Outlook 2010. Okay, if the original server's there, it'll say, okay, I recognize the change, but I can still talk to this old server, so I'm still going to talk to this old server. And it will do that, but if that server goes away, Auto-Discover is in Outlook 2007 as well. It will detect that change and automatically update the profile and connect to the proper server. Now, Outlook 2003. What does Outlook 2003 do? Well, it's got its home server profile, so it's going to connect to that same server. It doesn't have Auto-Discover. It doesn't know anything has changed or how to respond to any changes. All it knows is that's the server it's supposed to talk to, and that's the server it's talking to. If that server goes away, though, life is pretty bad, okay? Because Outlook won't do anything if its source server isn't around. It's at this point where the administrator would have to go to the Outlook 2003 desktop and manually update the profile. Okay, in fact, in this case, a profile repair will not fix it because Outlook gets the repair information from its original source server. Okay, now, up until this point, and it's not in the deck, but it's an important aside, up until this point we've been focusing on the experience with mailbox databases. How many of you are using public folder databases? How many of you are using public folder databases in Outlook 2003? Okay, so you know then, you know from experience perhaps, that if Outlook 2003 can't connect to a public folder store, it's not connecting. Now, you may have heard that we don't allow you to use continuous replication for public folder databases, and we don't. It's for mailbox databases only. So what that means is you also have to be concerned about public folder replication as you're replicating this data across to these other data centers. Okay? If the public folder data is not there, it doesn't matter whether or not you've allowed cross-site connections or whether or not profiles get updated and so forth. Outlook simply won't log on to the store and it won't connect. Okay? Keep that in mind. Now, there's also a small bug in Outlook 2010. Well, okay, small, big is relative, but there's a bug in Outlook 2010. It's a bug. And it's actually not a bug, it's more of a take-back. We had this functionality in Outlook 2007 that said when you go to connect your public folder database, if the public folder database returns error code wrong server, EC wrong server, you can ask for a referral and get a referral to the server you should be talking to. And then Outlook 2007 gets that referral and happily connects to that other server. Okay, so Outlook 2010 comes along and says, I'm trying to connect to this public folder database, and it gets the EC wrong server. What does it do? Nothing. Okay, the code for it to do that redirection is gone, unfortunately, in Outlook 2010. It's on its way back. There's an open bug, and there's good reason for the Exchange team to want that back. But right now, in all versions of Outlook that you can get your hands on, it's not there. Okay, so what that means, unfortunately, is that Outlook 2010 is not going to be able to do anything with public folders unless you're able to get a public folder store to it. Now, it doesn't need it to log on to the store, so it's not going to block mailbox access like Outlook 2003 is. But the point is, if that Outlook client needs that public folder data, you're going to go out and have to modify the property on their mailbox database to point to a surviving public folder database, or they won't be able to get to that public folder data. So that will be more of a disaster recovery type procedure than a high availability type procedure. Okay, and I mentioned I would talk briefly about the other clients as well. So the behavior depends on whether it's a star over within the site or outside the site, and of course what client you're using as well. For most of the clients, when you're talking an insight star over, it's going to be a reconnect. Okay, it's just the database moving to a different mailbox server. That's all completely abstracted from all the clients. Nothing changes from the client perspective. So all of them will just reconnect. Some won't even need to do that. Failovers and switchovers can happen in less than 30 seconds, and actually some are taking place in 5-10 seconds. So many of these clients won't even know. And in fact, some of these clients, if you happen to be an Outlook web app and your database goes out from underneath you, we've got two cool things that will help improve that experience. One is that now in Outlook web app, we save your work in progress to your drafts folder. Okay? So if things go away out from under you, you no longer lose your work in progress. We've got that saved in the drafts folder. The other thing is we don't require you to log back on. If your database goes out from under you, you might get a message that says, your database is not available right now. Please try again momentarily. You hit F5 to refresh. Boom, you're back in your mailbox like that. You don't have to sign back on. And again, you're only going to notice that if the timing just happens to be right during one of these star overs. Now, if it's out of sight, obviously there's going to be different behaviors depending on the clients. Some Outlook web app clients, they might have the manual redirect, where they use the URL that you're used to, and instead of getting the login page, they get a message that says, there's actually a better URL for you to use now. Click here to use it, and then they have to sign in and everything. For some, for Outlook Anywhere, depending on what version of Outlook you're using and the nature of the failure, it might be an automatic reconnect, partially through auto-discover as you saw, or through whatever RPC client access property was set on the database. For ActiveSync, IMAP, web services, again, it's going to vary based on the protocol. And of course, for data center switchover, that's a DR event, not an HA event. That's why we call it a data center switchover. There's no such thing in Exchange as a data center failover. Hey, data centers don't get automatically activated in Exchange because from an Exchange perspective, that's a business decision. That's a human making that decision, not the system. Now, you can automate that switchover, so it can be very fast and happen quickly, but it won't be automatic. The system will never decide to do a failover for you. And it can't anyway. Even if it could move all the databases over there, you still have all the namespaces and everything to deal with. So it's always going to be a data center switchover. It's always going to be a manual process. Therefore, it's always going to be a manual reconnect on the part of the clients once they've picked up the new DNS entries for the namespace. Okay, let's see how we're doing on time in terms of questions. I think we should have time, but again, I don't want to make you late for your lunch. All right, yeah, we've got about 2 minutes left for questions, so happy to take all the questions that you have. And for those of you who don't have questions, who are taking off, please don't forget to fill out your surveys. It's very important. Okay, let's start with questions over here. So the question was, I talked about the content index for mailboxes and how many indexes are there for each database. There's only one content index per database, and it covers the entire database. So all mailboxes that are in that database will feed into the same single index, and then it's that. That's correct. If you have 50 databases, you'll have 50 unique indexes for that database. Yes. Yes, sir. Mm-hmm. That's a great question. If you have a 2-server DAG that's co-locating all the roles, CAS, hub, mailbox, how does the transport dumpster work in that? That's such a brilliant question. We actually have intelligence built in. We changed our behavior in 2010. Remember, in 2007, that wasn't an issue because you couldn't locate hub or CAS on an HA mailbox server. Because you could in 2010, we changed the logic inside of our mail submission and in our transport. So what we do now is if I'm a hub and I need to deliver a message to a local mailbox store and there's another hub in my site, I'll send it to that other hub first and add that extra hop so it goes into that transport dumpster, and then that hub sends it to the mailbox. Now, obviously, if there's no other hubs, if it's down for whatever reason, we deliver the mail, and you don't get the protection there. But as long as there's another hub anywhere in that site, we'll add that extra hop and get it in a transport dumpster that's not on the same server as the mailbox role. Similarly, if I'm the mailbox role and I need to submit now to a hub, I no longer prefer the local hub like I do in 2007. In 2007, I always prefer the local hub. In 2010, if there's another hub that's not on my box, I will go ahead and submit that message to the hub for delivery instead. The reason for that is in addition to transport dumpster, there's another feature called shadow redundancy. Shadow redundancy, a lot of people know that from the protocol implementation where we do it in SMTP, but there's also client implementation where after Mailbox has submitted a message to Hub, if Hub can't deliver that message or it loses it for whatever reason, shadow redundancy kicks in and actually goes to that user's sent items folder and picks the message up out of there and resubmits it into the transport pipeline. So we'll try to get it to another hub, and if we can, we'll submit it through the other hub. If we can't, it'll just go out through the normal one. But if that happens, we've got shadow redundancy protecting that in case that normal single hub can't deliver it. So great question. Yes, sir. Mm-hmm. Possibly. It depends on the nature of the failure, where your databases are, whether or not you may be willing to tolerate some data loss there, depending on how many logs made it across. Yeah, at any given time, though, you're going to only have one subset of that group active, and you can't have it both be at the same time. So if you are going to terminate one, then because the other is not up to get those changes, you're going to have to try to surgically, manually copy those changes over to get things up and running. So I would say avoid getting into that situation in the first place and just build the resiliency in the way you need it instead of having to flip one for the other, or use 2 DAGs like you saw in the other example, so that if you do lose connectivity, each side stays up locally. You lose data redundancy because you can't ship, but you have service availability. Well, for each DAG, they would have a witness local in the data center. So when the WAN goes down, half of each DAG would survive locally. You'd only lose the remote side, which couldn't maintain quorum. And I'll be going a bit deeper into that in the deep dive session, which, by the way, is not in this room. It's in the Marlboro rooms. Yes, sir. Mm-hmm. Then you don't have enough servers to do 2 DAGs. Yeah, then you'd either have to tolerate one data center going down if you lose your WAN link. Optionally, you could put redundancy into the WAN link, which is going to be prohibitively expensive, possibly. Or you buy sufficient hardware, enough hardware to have multiple DAGs. Yeah. Yes, sir. Great question. Does file share witness have to be 2010? No, it does not. It's super easy if it is. If it's not, you do have to add the Exchange Trusted Subsystem Universal Security Group to the local administrators group on the witness server. Otherwise, we can't use it. We need permissions to manipulate it. If it's a 2010 server, we already have those permissions, so we can do that. But if it's not, you just add that group and you're good to go. 2003 or later, provided you're not clustering the witness server. If you did want to cluster the witness server, which you don't need to, and I'll explain why in the next session, but if you did want to cluster it for whatever reason, you have to use Windows Server 2008 for that. But otherwise, Windows 2003 anywhere in the forest.